this computer. Uh, to see what happened to the videos when they were all glitchy like that. To see if it's still recording my end. So.
Okay.
All right, so I wanted to ask y'all, did y'all try the cube root one?
Mm-hmm.
Yes.
Did y'all get it to work?
Yes.
Yes.
Yes. So, did anybody have it written down?
Yes, I do.
You have it. So, how about Faith?
And I can show you my screen because
Yes.
I scanned it in.
Oh, cool.
So I'm going to try and share my screen right now, okay?
Okay, so you're going to share your screen?
Yep.
Okay.
Okay, can you see it?
Yay! Yes, I see it.
Okay, I didn't try to draw the
cube. Yeah, it's not an easy thing to draw.
Yeah, I wasn't gonna do that. So, so I've got this up here, and then this expansion I found really helpful, like just to keep in perspective of what I was doing, like the different steps. So the A part was still the same. We just had 100A and we cubed it now, right? And then the smallest A, or the largest A, sorry, that worked for that was 2. That got us 8 million. So I subtracted the 8 million from the total number, and now I worked with this number to do the whole B step. I found that easier than trying to write out the part with the A as well and subtracting all of that. I don't know. It simplified it for me. And then now find the largest B, such that all of this jazz, which was right in the book, I would never have been able to figure that out from the drawing.
Yeah.
So you just plugged in, or you put your A in here. That was something that I almost tripped up on. I almost did the 100 example that they had in the book, but I was like, oh no, we're multiplying the 100 by our A, and their A was 1, our A is 2, so we have to put the 2 in here. So, and then do all of this, simplified it a little bit, and then kept plugging things in until I got 3. 4 was too big for B. And then subtracted this number, which was what I got when I substituted in B for this, B into this. And then subtracted that from the remaining like volume that we're working with is how I was thinking about that. So this is the volume we're taking away with our B's. And then we have our C, this, and then C equals 4 gave us that perfectly. And that's, so 234 is the cube root of that ginormous number. That make sense? Okay, I'm gonna stop sharing my screen now, okay?
Okay.
Unless you want.
Oh, unless Abby and Jared, do y'all have any questions?
No.
Did y'all's work look any different?
No, my work, Jared showed me like how to do it kind of yesterday, but we got the same work as she did.
Cool. Awesome.
The only thing I don't get is where they get that last formula, like for C. Like the C times 3 times 230 squared plus, I don't know. I'll explain.
Well, I kind of thought about it, like at least the 230 part, because we have our 2 and our 3 already for A and B. That's where the 2 and 3 comes from. And I'm not quite sure where like the multiplying 3 by it goes by 3 comes from. I agree with that. You're not able to like visually see that in the cube. It's just hard for me.
So, Faith, can you show your picture again? Did you lose me?
It's right here. Oh wait, no.
There we go.
You got it? Yes? Okay.
Yeah.
So it's right here,
Yeah,
This-
that line.
this formula. So I
Yeah.
can see where the 2 and the 3 came from because we've already figured out A equals 2 and B equals 3.
Mhm.
So, but we're just wondering if there's an easy way to think about this 3 aspect of it.
Because that gives you, because I'm trying to relate it back to the original expansion.
Huh.
So,
Oh, this up here?
yeah, the R plus S cubed part where we expanded that out. Because essentially the way that we're looking at this is,
Okay, does it have to do with like this aspect of it?
so like if we look at R plus S quantity, oh, you don't see what I'm saying. Okay, hold on. So let me share my screen to, no, I don't want to do that either.
I can stop sharing this one and we can hop over to yours.
Yeah,
Is that good?
yeah.
And then, yeah, there you go.
Yeah,
You can
so
see you're done.
So the way that I was seeing it, like, and exactly like what we did when we did the square root one. So our number was 234, right?
Yes.
Mhm.
So like, I started trying to view these numbers as like, say like, our like, so we found A and B, right? So then we could view this as 230 plus 4, or sorry, that's cheating. S quantity cubed, right? So that would be the S term. So that's our C.
Yeah.
And so these terms here, those S's now are technically our C's. So that's how I was seeing that part of it. I don't know if
And
that
this
makes any sense.
Yeah, this expansion, the second and third terms both have a 3 multiplier. So that's where the 3 was coming from.
Right. Because if you're starting to look at all the little tiny mini cubes inside that cube that are all pieced together,
Mm-hmm.
they're following those expansions in some way or form. Does
Yeah.
that make sense?
Mhm.
So that's how I started.
Right. Yeah.
Technically, we are doing this 200 plus 30 plus, then we found the 4 quantity cubed.
Yep.
But we definitely have a binomial expansion. This just gets a little bit more complicated. But if we expanded this number out, those little tiny pieces that we found at each of those stages, those would have ended up showing up in that shape or form, is what it was doing. So it looked like they had a really keen understanding of binomial and trinomial expansions before even defining it as such.
Yeah.
So that's, does that kind of help you visualize why they're coming up with it that way, Jared?
Yeah.
Yeah. So, ouch. So yeah. All right. And we talked about the hypotenuse diagram. So that kind of knocks that out. By any chance, did y'all look at the method of double differences?
No.
No.
Mhm.
Not part, yeah. So this is a little bit after the fact. But I think I feel like that makes more sense with the square. I'm still surprised that they were able to figure that out. But like my confusion is with that the whole square root in cube root, what happens when it's not a cubed number or a
True.
perfectly square number? I don't think they didn't talk about that, right?
Well, I
No.
think that you would just end up with a remainder once
I
you
got
do
some
like
something.
Yeah.
once you do your C term, you just have something left over, and they
Yeah.
know that it's not a perfect cube or a perfect square.
Squared, yeah.
Didn't we have something left over in one of them though? Or not?
We did, but we just didn't take it to like the. I think that was with one of the squaring ones, and we didn't take out the C squared term, so we just left the last box for some reason.
Oh, we didn't finish? Well, because the only ones we did were the ones that were in the book, right?
Mm-hmm.
Yeah, for like the 3, okay, what number was it? It's the square root of 142,884. We got,
Yeah, we got the square root of that one.
yeah, but the number was like it had a remainder left. The C, if that makes sense. Right? Or not?
No, it's all good. So my last step on that problem was 740 C
Yeah,
that are equal to 509
84.
5,984.
Yeah,
That's
we
what
got
I
it.
had too.
We ended up getting,
It was 8.0864.
because if we did,
Because that's a remainder, right? That'd be a remainder.
I get you. So we have our 740 C times 8,
Yeah.
which gives us 500 or 5,920.
there it is.
So the difference of that is 64, which is 8 squared, which is what I was saying about the last square of C squared. We weren't taking that out.
Mm,
Do you see what I'm saying, Joni?
yeah, I got you.
You mean this, or is it this one? Wait, no, this is the one we did the other day. Hold on. I found, like, I had the first half of it, and then, like, number 4 is just gone. Hold on. That is, it was written in a turquoise pen. There it is. Okay.
Yeah.
This one, right?
Yeah. And we were lower. It was down here where it was.
Yeah.
Yeah. There was a remainder there.
Oh, technically, so this would mean D is going to be, so if we made that a, should have been a 9. Right? Because we always had the whole numbers. They always write it with whole numbers.
Oh, so you're saying that 9 has to be greater than C, so C equals
Is
8.
8.
Okay.
Yeah.
So it's just a different way of writing.
Yeah, I just did it this way because this is what we were used to. Right?
Yeah.
So, like when I did the long division, I had 8 and some change, which means that C has to be less than the biggest integer of that number, right?
Yeah.
Mm-hmm.
Yeah, because they only used whole numbers.
Okay.
So yeah.
So they didn't have decimals or.
Well,
They,
doesn't
assuming they did simple
look like
fraction.
that I've seen so far in my readings and even like all the stuff that I've been reading online, it looked like they just dealt with whole numbers. Granted that they have a decimal system, but I don't see it in the readings here. So yeah, because it all looks like when we get to solving the equations, they have fractions, but it looks like it gets translated into like modular notations.
I don't know what that means.
So like because we haven't got to the Chinese remainder problem yet. So like what they would do is say like, for example, say like 7 mod 3.
Oh, okay. I remember that vaguely now.
Yeah, I think,
Mhm.
did y'all talk about that in 215?
Yeah. Well,
Yeah.
yeah, it was 215.
Yeah, so that,
We've done a lot in 216.
so that would be a 1. So technically what you're looking at is 7 divided by 3, which is going to be 2 remainder 1, right?
Yeah.
So like when they looked at fractions, they were looking at the parts of, so this would be 2 plus 1/3. And that's kind of like how they were viewing some of these things
Okay.
and that modular stuff. So, which means that you're only dealing with whole numbers still. So, yeah. But let's see. All right. So I wanted to see if we could maybe look at this method of double differences. I thought the picture was kind of interesting. And this has to do with their 9 chapters book.
What page is that on?
207, it was part of the last part of the y'all's reading y'all were supposed to do.
Okay. Yeah.
Oh,
Oh,
and I was kind of disappointed. I don't remember us seeing anything in here about the abacus.
the abacus originated in China?
Well, they use it in Chinese mathematics a lot.
Okay.
So,
I didn't see anything about it either.
yeah, I don't see it in here. And it's still used today, so I thought that would be an aside. Oh,
Hmm.
so maybe on Tuesday, I'll have for y'all to read while I'm thinking about it actively now. If y'all can read uh 7, 4.
For Tuesday, you said?
Yeah, because like tomorrow is gonna be optional day, and I would like y'all just kind of take the day to work on y'all's papers, y'all's next paper project. Is that okay?
Mm-hmm.
So yeah,
When is that due?
that's a good question.
I think it's like the week before finals,
Yeah,
unless you changed it.
nope, I did not change that. I did not
Yeah.
do it.
Are we gonna do like, we have to do a problem if we did a person last time?
Right.
And then do you still want us doing like the PowerPoint so we can?
Yeah, we'll
Do
do
it.
that. On that last day of classes before the final.
Okay.
So like it'll take us 15 minutes to do y'all's presentations, if that, and then we'll spend the rest of the time talking about things that are going to be on the final. Granted, it'll be a take-home final since
Okay, that was my question. I was
yeah, everything from here on out is all take-home. Like they're trying to figure out how to do finals through proctoring, but
Mhm.
apparently it's $25 a proctored exam.
Wow.
Yeah, which obviously should not fall on y'all. So it's falling on the school. And if I have 85 students this semester,
Oh,
that's
25 per student?
$25.
You
Okay.
multiply anything by 25, or multiply 25 by anything, then that's gonna get pricey really fast.
Well, I told them that I was gonna do that, but I haven't had problems with cheating on the take-home stuff that I've done this semester so far. Granted, I had cheating for the in-class exams, so
Dang.
I mean, it seems to be going fine, and And after they told me that, I'm just kind of like, no, I don't feel like that's justified.
Yeah.
So
I mean, I've like, so it's $25 for like a person to proctor or for a software to proctor? Because I've
for
had
the
software.
software proctoring,
Really?
yeah,
Because of all the data and stuff that
I
they're
guess so. Like, I'm not really sure.
Yeah, I'm fine with take home. I
Yeah.
like that a lot more than proctoring.
Yeah. So, I mean, I feel like y'all are still getting the same questions. Granted, I will have y'all explain a little bit more, and y'all did absolutely fine. For those of y'all who took the first test in class, like, y'all still did fine on that. So,
You know, we can't memorize the information if we need to.
yeah. So, I think it's fine.
Okay.
So, unless you really, really, really want to do it that way.
No, I don't.
I mean, I'll go back and tell them I will change my mind, but
No.
so, yeah.
So just 7.4 for Tuesday.
And 7.5. The Chinese remainder theorem is definitely
Sorry,
something
guys.
I want us to go over. So I would say I would focus more on 7.5 as opposed to solving equations. But yeah, so primarily focus on 7.5.
Okay.
Because they want you to solve like quartic equations, and which is cool and stuff. But yeah. I'd rather y'all focus on the Chinese remainder theorem, because that's something that is something you can teach in middle school. And it's related to some of the stuff that y'all did in 103 with the Euclidean algorithm. So there's some parallels there to what they're doing. So yeah, I would like y'all to look at that. Okay. So, okay. All right. So I kind of wanted us to see if we could look at this method of double differences. And just to observe what's going on in here. So that's on page 207. So they have this picture. So they have, so they're talking about surveying question. So they're talking about finding the height of an island.
Interesting.
So they have this triangle A and C and R. Then they label this point B. And then they have K, which makes this intersection E, and then that intersection M. Then they drop these perpendiculars down. That's an F. N. And then they copied what happened here. No, let me make that a T. So now I have all my letters. So the distance between F and N was B. The difference between N and R is C. And then this distance here is H. And then this here, S, we called him A. So that would make this guy A. And then F to K is D, right? Make sure I read that right. Yeah. So the distance from B to C would be
A.
A. Yeah, that's okay.
Could you put it down a tiny bit?
Yeah, yeah.
Thank you.
So this is the first picture. So it says, they then ended up using constructions essentially to then draw that picture. To make a rectangle. So let me do this in a different color just so we can see that extended out. Oh, my blue pen is up. Hi. So then we have these two new, oh, they don't label those 2 points. So there's that and that. And then all right. So now we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 1, 2, 3, 4, 5, 6, 7, 8. I'm missing you. H. Now I have everybody. So they say what's going on here. So this is called the method of double differences because it says that the two differences are used to find the solution to the procedure. All right. So it says construct MT parallel to EK. So this line is parallel to this line. So we have a parallelogram there, right?
Mm-hmm.
And so that's what happened there. And then we have triangle AEK is similar to triangle MTR. Why? So we're looking at AE. They said A.
Yeah,
Oh,
AE.
M. Right? And okay, because like that's a line. AEM. So this triangle.
Okay.
And then MTR. Well, if these are parallel and that's parallel to that, this angle is the same as this angle.
Mhm.
And since these two lines are parallel, that angle is the same as that angle. So that would mean that AEM, so if I pull that guy out, and then we have the little one. Is that you, Faith?
Oh yeah, I'm sorry.
No, you're fine.
I didn't realize that he was making noise. My mom does like daycare for.
Oh, okay. I didn't know if that was like, is that your
Foster mom.
sister?
No, it could be though. Oh my goodness. No, he's a 2-year-old.
Oh gosh.
I'm gonna mute my mic so that he
Oh,
might
no,
start
you're fine.
screaming.
You're fine.
Alright. Okay, so I know that those two angles are going to be congruent. So I need at least to show that somehow these are proportional, these sides are proportional, or these angles are all the same. So how do I get that part?
Wouldn't the top angles would be the same, A and right?
Why?
Because
Oh, I
they
see.
both intersect the same like line, kind of.
So, because this is here, here.
Mhm.
Okay. Yeah. So,
How can you say that's true though? Why can you say that?
okay. So let's see. The way that this is constructed, so this is coming out of a right
Yeah.
triangle, right?
hmm
And so if we look at this, I know this is a parallelogram, okay? Because what I'm seeing here is this big one out of this rectangle, but it looks almost exactly like a copy in this little rectangle here, right?
Yeah.
So if we can somehow show that these end up being the same kind of constructions here, that would definitely imply that. But let's see. Just based on this drawing, I'm trying to figure out if this would be the same. So if I had this parallelogram, this angle is the same as, or sorry, this angle plus that angle is going to be supplementary. Then, make sure that looks like that. Okay. So AEM is supplementary to KEM, right? Because they're on the same line.
Mm-hmm.
Let's do that real quick. Okay. Now, this angle is the same as that angle. Oh, I don't have a parallelogram.
But it's like that one line. What is it? AR intersects both the parallel lines, so wouldn't they have the same angle?
Oh.
So AR is a transversal for those two. Because I'm looking at, so there's EMKT, right?
Mm-hmm.
And then AM would then be a transversal for those, right? So there's A out here.
Mm-hmm.
So this angle would be the same as that angle. Yeah, you're right.
Then we have angle, angle, angle because
Yeah, we would have,
the ones on the bottom line are
yeah,
we
so,
are
yeah, so by angle, angle, similarity, those triangles. So this would be by angle, angle. Okay, we got that part. They also say triangle MTR, or no, ABM. Reading the wrong line. Triangle ABM is similar to triangle MNR.
mhm.
So why? So we have this one ABM, so that's this guy. And then MNR. Well, B is a right angle and N is a right angle.
Mhm.
Mm-hmm.
And we already have said, nope, this is a different triangle.
It's another like intersection.
So it's going to be like on the same level there. Because we're going to now be talking about this angle together here, right? And then this
Mhm.
angle here. That's what we're trying to show, right?
Mm-hmm.
But isn't AC parallel to LN, so it'd be the same?
Same thing, yeah. So then this would
Mhm.
be by angle, angle. So now they are saying that we can use this information that ME to TR is going to be the same as AM to MR, which is equal to AB to MN. So that's true. AM to MR is true. AB to MN. Why?
Because isn't that what we just did with the last one?
Yeah, so this is coming from these two triangles, right? The
Yeah.
ME to TR, that's this one to this one. AM to MR. And then I believe that, but how do we say that this is the same from here to here?
Oh, that the similarities are the same is what you're saying. Okay.
Yeah,
Like we can make
because
that
we're,
relation,
because
but
we're looking at two different triangles then now, right?
Mm-hmm.
yeah.
So why is that true? Because M to R is the same in here. Okay, I believe that. Oh,
It's just extensions of
uh-huh.
same triangle. You're just moving.
Yeah. That is tricky.
That's kind of cool. Because you just pulled the E over to B and pulled the T.
Right, yeah. Wow. I feel like that took a leap. Interesting. Okay. So then, oh, we're already over time. Damn it. But we have,
How did you
We're
get
close.
it to pick us out?
huh?
I
Huh?
thought it was like a 40-minute.
No. Oh, so the school gave me my own code. They bought us codes for those of us who were using Zoom. They paid for our code because it was cheaper for them to buy like 20 codes at a time as opposed for each of us to buy our own code. So there was like 16 of us who wanted that, and it's like $30 a month for 16 people, or buy 20 and it was like a third of the cost or something.
That's pretty cool.
So yeah, so I have my own code now, so they don't kick us out anymore.
Yay! I was
Or
like,
I could just say, Jared, you don't show up today. Then we could have talked as long as we wanted. Because it
I'll
only,
leave.
yeah, it cuts it off for like if you have more than 3 people in a meeting, you have a time limit in the free account. Once you have that 4th person, it's like, oh, now you only have 40 minutes.
kind of makes sense
Yeah.
for like on their end of things.
Yeah.
But that's cool.
So yeah, so I have my
You
own
don't
code
have to
now.
come into to 420 like 3 different times.
Right, yeah. So we will get to watch it all at once. And like that was one of the things, like when I was starting to make that activity for y'all, was just like I would have to use one of those time sessions just for y'all to watch that class. If we were to watch it together, which I felt like was a waste of time.
Yeah.
So
Cool.
yeah. All right. So let's just finish this real quick.
Yep.
So then it says that if I use these, I can say that AB is going to equal to ME times MN. That's fine. I believe you. Divided by TR. So that's just looking at that inequal, or that part, right? Solving for AB. Which then they somehow jump here to saying this is going to be equal to FN times EF. Over TR? Why? That's the part I don't get. ME,
Well,
there's FN, so those are going to be the same, right?
it's a
ME is
rectangle.
the same as FN because those it's a rectangle in there, right?
Yep.
And then MN is this piece, so that has to be equal to that piece.
Yeah.
Yeah, now I believe them. All right. And we know H, that distance, so we're trying to find H is what they're trying to say, is FN, or no, that's jumping the gun. H is going to be AB plus BC, right? That's just from our drawing, right? So then if AB is that, so H is going to be that FNEF, because that's going to be AB is this piece.
Mhm.
And then BF, or sorry, BC is equal to EF. And then you just substitute that stuff in there with the little letters, and now you would actually have, so FN is B, EF is A, so you get AB, and then TR, here to here, is going to be C minus D, because that's going to be translated over here because those are similar. So that'll be C minus D. And then who is EF? EF is just A. That's where that came from. I believe them now. So, because obviously we can't measure the height, but if we are able to measure these shorter distances, we could actually figure that out.
That's crazy.
So that was kind of like using like Archimedes stuff, right? Like using similar triangles.
Yeah, it reminds me of that a little bit.
Yeah. All right. Okay, so for next time, now that we're 7 minutes over, focus primarily on 7.5, and then I will put together an activity on an abacus,
Okay.
because I think that would be fun for y'all to do in school too. And
Did
it talks about place value.
You said that you were gonna write out some different things.
Yeah.
Did you upload those yet to Moodle?
I know I haven't finished them yet. I'm working. I'm sorry.
No, I completely understand. I'm just making sure that I'm missing things and I'm not falling behind on the readings that you're putting up on Moodle.
Yeah, I'm working on it. So, and I also want to upload these notes somehow in an organized manner, so that way y'all have those as well. I mean, obviously y'all could watch the videos. Have y'all clicked on those links yet that I uploaded?
Yeah, I watched the one that I came in late to and it worked fine.
Okay, I just wanted to make sure that they were working right. No. I have a bunch of them converted now. I just need to upload them. So I just need to sit down and do that.
Cool.
Yeah. All right. Well, I will see y'all guys on Tuesday then, right?
Sounds good.
Alrighty. Well, bye guys, and see y'all. Are y'all going to that ed meeting?